In chemistry, compounds react together in specific proportions, determined by their ability to bond. As such, it makes more sense to deal with quantities in units that can be universal, regardless of the element or molecule in question. So enter the mole. A mole of material is the same quantity of reacting material regardless of its identity. So, for example, 1 mole of hydrogen reacts with half a mole of oxygen to make 1 mole of water. 1 mole of hydrogen has a different mass to 1 mole of oxygen, and this is because of the different number of protons and neutrons in it. So 1 mole of hydrogen weighs 2 grams, and the reason for this is because there are 2 hydrogen atoms bonded together, each with a mass of 1, and because we have 2 of them, that adds up to 2. Oxygen, 1 mole of oxygen, has a mass of 32 grams, because you have 2 lots of 16, giving us a total of 32. 1 mole of water, on the other hand, because it is made from 1 oxygen and 2 hydrogens, is going to have a total mass of 18 grams for every mole of water that you have. To use this principle in practice, there are several skills you have to master. The first we should be looking at is how to calculate the gram formula mass, or GFM. This tells you how much 1 mole of material weighs in grams. First of all, you need to know the formula of the compound in question. So let's start with water as an example. Water has a formula of H2O. So what we need to do is to work out, first of all, the mass of each element that's present in this formula. Easiest way to do it is by this sort of shorthand notation. Oxygen has a mass. If you look in any Databook or in some periodic tables, it will tell you the mass of each element. And you'll find that oxygen has a mass of roughly 16. In the formula for water, we've only got 1 atom of oxygen, so we multiply that by 1, giving you a total of 16. Hydrogen, on the other hand, as we saw earlier, has a mass of 1. And in the formula for water, there are 2 of them, so we multiply that by 2, giving us a total of 2. Now we add these 2 numbers together to give a total mass of water, which is 18 grams per mole. So for every mole of water, you have 18 grams. Let's try another example now, that of sulfuric acid, which has the formula H2SO4. Once again, let's start with the oxygen on the right. Oxygen has a mass of 16, and in the formula we have 4 of them. So 16 times 4 is 64. Sulfur, if you look it up, has a mass of 32. There's only 1 of them in the formula, so you multiply it by 1, and we get 32. And hydrogen, once again, has a mass of 1. We times it by 2, and we get 2. Now we simply add all these numbers together. We get a total mass of 98 grams per mole. One more example now, with the formula of calcium nitrate. Now this one's a little bit different because we're introducing brackets into the formula. But what the brackets mean is everything that is inside those brackets is multiplied by the number on the outside of it. So in the case here of oxygen, we would normally have 3, but because we've got a 2 on the outside of the brackets, we've got to double it. So 3 times 2 is 6. Oxygen, of course, has a mass of 16, so 16 times 6 gives us 96. Nitrogen has a mass of 14. We've got 2 of them, because there's 1 in the formula multiplied by the 2 in the brackets, and that gives us a mass here of 28. Finally, calcium. It's outside of the brackets and we only have 1 of them. The mass of calcium, elemental calcium, is 40 times by 1 gives you 40. Now if we add these 3 numbers together, it comes to 164. So that's a very quick tutorial on how to calculate GFM from molecular formula. Any questions, please leave them in the comments below.